what I'll do, I'll going to insert the my list. That's the first list, and with this list I'm going to declare three variables over here. So with these three variables I'm going to import NumPy as np. So NumPy as np, I'm going to print this array size, and array will have np dot array. I'm going to convert this list into the array. So this is the type conversion. So I'm having my list over here, and then I'm going to print this type or oblique class of this object. So what I'll do, I'll write the print command and give the type function with the round bracket, and then I'm going to print the array itself. So what's the value array, and then I can have the NumPy. So you can see NumPy is having n dimensional and array is having 1 2 3. These are the array dimensions, right? Similarly, I'll have my met. This is the second dimension or 2-dimension array, right? So I'm going to create a list. Inside the list I'm going to create one more list. That's 1 2 and 3. So the second part I'm going to create one more thing, 4 5 and then 6. Then I'm going to create one more list, that is 7 8 and then 9, right? So again going to repeat this value, inside the different next variable, that is the met, and np dot array. I'm going to convert this array into the different format. This is the my met variable which I initially just defined over here. Then I'm going to define the different outputs. Like suppose I'm going to define the type of this variable. So using the type function I can define the type variable. You can see this is the again n dimensional array. So the class relevant to this my met is 1 2 3 4 5 6 2 dimensional, and the 1 dimensional array itself, right? So you can go for the different values, like different size, like what is the met here. So met is the 2-dimensional value. Suppose I'm going to print met. You can see it's a 2-dimensional array. Again, if I want to check the dimension of this matrix, so what I'll do, I'll write n dimension. So met is my variable, and now I'm going to add this one, right? You can see this is the dimension 2, right? So what would be the shape? All right, so what would be the size of this matrix? Suppose I'm going to write mi met and then size. So I'll write met dot size. You can see 9 elements are here. So 1 2 3 4 5 6 7 8 9 elements are here, but dimensional means x versus y, it's having 2-dimensional values. So let me allow me to create more size values. Now I am going to create what is the shape value. So shape is what SHAP function. I am going to create the shape. So this is the x cross y or n cross y, so 3 cross 3 shape of this matrix, right? Suppose I want to check the data type. So what is the D type? I'll use D type for this matrix. This is of integer 32. All the elements are of integer data type. So I'll make it shape gives the number of elements along each axis. So that's the dimension and the size, right? So data type gives the data type contained in the array. So I'll having integer 32 everywhere. So this is the array, means array data type, right? Similarly, I can go for the different values. Suppose I am having the same array, but courtesy I'm going to copy this array and going to print this one, and I'm going to create one more dot over here, let's say 1.1, and additional thing I'm going to create 5.2 and any value with the third variable 8.3. So I'm going to run this code, and now I'm going to type the data type of this value again. Now you can see this is of float 64 because few elements are of float. Now data type modified matrix now given over here. Even we can have another values, like suppose we are going to declare b is equal to np dot array, and we are going to have convert this array into the different array. So this is the first square bracket, and then I am going to create the 1.5 comma 2 comma 3. Actually these are the tuples, right? So tuples type of modified matrix, and we can even tuples can be converted into n dimensional array. So we are going to convert these values, so 4 5 6. So that's the first value, and we write these value into different matrix formats. So these are the not value. So I'm going to print this b over here, so you can see they are printed over here, right? So they can have the simple values, right? Now let's check what are the series, right? What are the series and Linspaces or arrange function or Linspace, arrange, and how Linspace works for my different values, right? So for this I'll write np dot arrange, simple arrange is the function, round bracket 5 comma 60, that's the function value, and then I'm going to create these function values with my certain values, right? So these functions are predefined, and I'm going to run this code, and you can see 5 to 15 values are just created. This is my one dimensional array, right? So you can see values starting from 5 till 15 are just created over here, right? Now we can have more the numbers, like suppose np dot arrange, now I am having 0 comma 11 comma 2. So this is a different kind of arrange. So at the interval of 2 I'm going to create this arrange function 2 4 6 8 and 10. So I'm going to create this arrange, and but the last value, second values are pruned or escaped. So I'm having regular interval of 2 but creating these arrange values, right? Similarly, if you want to create the numbers spaced apart by float values, so what I'll do, I'll write np dot arrange, same function 0 comma 11 comma 2.5 and hit run. You can see now values are separated by float variable with decimal separated values, so they are apart by float values, right? If you want to create every fifth number from 50 in reverse order, right? So what I'll do, I'll write arrange np dot arrange, and then I'll write 50 comma minus 1 and then minus 5. So this is going to create the starting from 50 till minus 1, or it will skip this minus 1 till 0 it will have, and then minus 5, that is the minus 5 value. And now this is having 50 45 40 until 0 it is having decreasing order of the numbers, right? So every fifth number from 50 in reverse order are printing using np dot arrange over here, right? Let me check it out if we have any question. Okay, check it out if we okay, so we don't have any question. Okay, now I'm going to create 121 linearly spaced number between 1 and 5. So what I'll do, I'll write the np dot Linspace and then having 1 comma 5 comma 21. So this is for printing the, like suppose I'm going to print this, printing 21 linearly spaced numbers between 1 and 5. So what I'll do, 1 comma 5 and 21 numbers. So this is creating 21 numbers between 1 and 5, equally divided, right? Equally division into 21 partition. Suppose I want to create the 10 numbers Linspaces, so I'll having 10 division of my values. But what is the difference between arrange? So arrange, we will have the increment value of 10. So every time it will have increment value of the third integer numbers. But here in the Linspace we have 10 partition. The third number represent the partition number for the same, right? Now coming back to the next part of this session, we are going to create the zeros and the right. So zeros, 1 and empty. So I'm going to heading this one. Okay. So zeros, ones, empty and identity matrix, right? How to write these zeros? So suppose I am going to print this value. So I want to print the vector of zeros, right? So how to write the vector of zeros? I'll write np dot zeros and then we'll have 5 over here. So just you can see 5 times zeros are printed over here. Similarly, I can print more values with these functions. I can have the matrix for the same. So I'll use matrix of zeros and then n zeros with 2 dimensions. Let's say 3, 4. So I'm going to create 3, 4 values. So matrix of zeros. So I'll have to apply more parentheses over here. So this is the 2 dimension represent. Suppose I want to create one more line over here. So I need to insert 1/9 and then run. So you can see matrix of zeros are just printed over the screen. Similarly, we want to print the vector of ones. So I'm going to print the ONE vector of ones, and instead of zeros I can use the ones function, right? So ones I'm going to print over here. You can see these ones are printed over here. Similarly, I can go for the another number, print ones, but this time I want to print the matrix of 2 values. So matrix of ones and then np dot, again I'll have to insert 2 parentheses and then 3, 4. So now you can see the 3 rows and 4 columns are just created. So I'll have to create this installation. Now you can see matrix of ones are just created, 3, 4. So this is how you can create the matrix of different tuples and different values over there, right? So we can have the empty matrix over there. So how to print empty matrix? Suppose I want to print the so empty matrix. So empty matrix, right? And again /n to print from the new line. And now I'll have ones and then empty, right? So I'll print empty 1. So now you can see the empty ones are just printed over the screen and they don't have anything inside the value. Suppose I want to print the 3, 4. So I'm going to just I need to insert one more parenthesis and then I'll have 1, 3, 4, right? So this will create the empty matrix for the same, right? What if you want to create the identity matrix, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So what I'll do, I'll create the identity matrix using, suppose matrix 1 is equal to np dot I. So I is predefined function to create identity matrix, and I'll use the same function. So identity matrix, right? So this will be identity matrix. So I'll use mat dot MAT1, right? Just hit enter. You can see I'll have to insert /n for new lining, so I'll have identity matrix for the same. So this is how you can create the identity matrix for the different values. Now this the another thing, we can go for the random number generations. So I'm going to create one more heading over here, and here I'm going to create, okay, and then create the random number generation. So what are the random number generation function? It does like np.random.rand. I'll use the np.random function and 2,3. That's the random values over here. So I'll have to insert one more values and then hit enter, or just remove this number and just hit enter. You can see random number are just created. So you can create the generation from uniform distribution, right? So 2/3 matrix with random numbers ranging from 0 to 1, and means tuples are not necessary. Make sure you are not using the tuples over here. So I can create one more time. I am going to run this code one more time, and you can see the numbers are different this time, right? So these are the fundamental values for the tuples values. Now I'm going to use different random values. So random dot RANDN, right? So random with 4,3. So now you can see this time numbers from normal distribution with zeros mean and standard deviation 1, right? That is standard normal. So numbers from normal distribution with which will have 0 mean and standard deviation 1. So I can print this value over here, right? Before this I just hit enter, paste this one. So this is the numbers from normal distribution. If you find the mean of these values, so they will be 0. If you find the standard deviation of this number, you will have the you will get the standard deviation 1. So that's the normal function. I'll have to run this code again. Now you can see the numbers are different, but the fundamental condition is same. They will have average value as mean and standard deviation is 1, right? Now suppose you want to show these simple 20 numbers, right? So that is the, right, I want to print the n20 numbers. But see, n20 sample number drawn from dice through and random.ren integer, right? So 20 numbers I want to print, right? So 20 samples drawn from a dice through is randomly shown over here, right? 1 to 6, all the numbers are ranging from 1 to 6. So this is how you can create the 20 samples. If I run this code again, so now you can see the samples are again different. Run this code again, now sample are different. So this is how you can find out the different numbers. Now I'm going to create one more heading. So with this headings, okay, so this heading says going to illustrate reshaping, minimum, maximum and sort. How to sort the different values, different numbers. So for this I'm going to first import NumPy dot random, and then I'm going to import rand integer. So what are the rand integer here? You can see rand integer is representing whole numbers only. They don't have any condition with 0 mean and standard deviation 1. They don't have any condition with this one 0 to 1 value, but you will get whole number inside the rand integer using. So as of now we have seen 3 numbers over here. First is RAND, right? So first is RAND. Using RAND you just get the 0 to 1 value, but when you use RANDN, so this is the another function RANDN to generate the mean with 0 mean, all the values with 0 mean and standard deviation 1. The third one is RAND INT to generate all the numbers with certain integers. They don't have any decimal values. Now we have red integer. I'm going to coming back to this import file from numpy.random import red integer as RE. I'm going to decide this user defined keywords, right, alias number. So I'm going to define RI, so that is the random integer RI from starting from 1 to 100 till 30, right? So I'm going to reshape it. So how to reshape it? So I'm going to define a dot reshape function. With the reshape function I'm going to 2 comma 3 comma 5. So what is the significance over here? Okay, so let's find out. Cut C. Okay, just print over A. So you can see how many numbers are there. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23. Total 30 numbers are here. In between 1 to 100 I am going to generate 30 numbers, right? But this is going to, if you find the product of these three numbers, so 3 to the 6, 6 5 the 30. So this is going to reshape my value. If I'm going to print B over here, so you can see the same output which is one dimensional, like 30 cross 1. So if you find the dimension of A, so A dot shape, so 30 cross 1, that is the 30 only one dimensional array. If you find this this converted into 3 dimension, so 2 cross 3 into 5. So if you find the B dot shape and run this code, now you can see 2 cross 3 cross 5. So 5 numbers are just created. So row into column, you can see 1 2 3 4 5 1 2 3. So 3 into 5 with 2 matrix, right? So row into column, 2 matrix with the size of 3 into 5. This is the shape of B, and we reshape it just now. Similarly, I am going to create one variable A, that is again using reshape variable. With the reshape variable I am going to use 6 comma 5 and make sure the product is again 30. So 2 cross 3 cross 5, 5 3 ja 15 to the 30. So this is same as C A. So now you can see 6 cross 5 are generated over here. Alright, so we can have the same numbers on the screen. Now you can have the same values. Suppose you want to print the sorting values. So here is the sorted vector -1 np dot and then A values, right? So instead of A I am going to write a small a. So what is the kind? I am going to use merge sort over here and just run hit. So you can see my random numbers are just sorted over here over the A, right? You can see the different values are just sorted across the same matrix, and they are in the ascending order, right? So you can go for the different values, like suppose you want to check the like A dot max value. So I'm going to print the maximum value. So this is the 90 now out of the large array. Suppose I want to check the maximum value out of the B, so that would be again the same. So suppose I want to check A, the maximum location, right? What is the argument location, right? So ARGMAX and just run. So you can see this is the 5. So inside the A value, so you can see 0 1 2 3 4 5. So this is the first number I just printed over here, right? So here you can see the first value, first position of 99 is at index number 5. Starting from 0 0 1 2 3 4 5, the maximum number lies at index number 5. So this is the function to represent the maximum location of value. Let's see. So you can print in either way. Maximum of location, that is the 5, at the index value. Now coming back to the next section, we are going to discuss questions you may have. Okay, have any question? Okay, we don't have any questions. Okay, so tell me if you have any questions, then we can go with the questions number. Okay, so we don't have any questions. So next thing, I'm going to decide the index and slices. For this, I'm going to change the heading. Okay, just write this one, and index and slicing. So how to perform the index and slicing? So first I'll create the array value. So for this, np.arrange and then 0,11, and then I'm going to hit run. So this is how we can have the index value. Suppose I want to print the 7th value. So we know the arrange just assign the 0 to 11, any value in between. So ARR, I'm going to print the so all arrange or the sequence number between the arrange value, right? So if you find the 7, so it will give the 7 for the same. Suppose if you want to have the instead of 7, suppose you want to have 7 to 9, so you can have 7 to 8, only 2 numbers here. Suppose you want to have the -1 and the colon and the -1. So now you can see this is printing the reverse order of the value. So starting from -1 till the value 0 and till the -1, the index value is -1, decreasing from the last hand side. If I remove this value, so let me check, this will also give the index number last to first, right? Suppose I am having array, and then this is having -1 till -6 till -2. So how it is going to calculate from the last? So last number is 10, that is the index number -1, 9 is -2, 8 is -3, and so on till we have -6 over here. -1, -2, -3, -4, -5, -6, right? These are the range of -1 to -6. Now we want to jump to -2, that is 8 means 10, 8 and 6, right? I'm going to run this one, right? You can see 10, 8, 6 are just printed over the screen. So this is how you can print the simple values or simple index number from the last to different index number. Now we have an array is equal to np.arrange 0 to 21 2. So we know it just arrange at the regular number of 2 and starting from 0 to 21. So elements of 2, 2nd, 4th and index 9th are 2, 4, 9. So it is going to pass a list as an index to a subset. So I'm going to run this code. Now you can see the 4, 8, 18. So 4, that is the second, 0, 1, 2, 8, that is the 0, that is 8 over here, and that is the 9. So this is how we can pass a list as a index to a subset, right? You can print on the screen, right? Okay, so next we have, what are the next? We have conditional subsetting, right? How to print the conditional subsetting, right? Okay, so I think that's sufficient for today. Tomorrow in the next lecture we will discuss the conditional subsetting. All right, thank you.